Sharing the stream. All right. We are live on YouTube. I gotta wonder where Wolf is. All right, that can go up there too. That can go away. That's good. I gotta send out the reminder. That looks good. So, what's going on, kids? Not much, huh?
Well, it's been a big day preparing to watch this wonderful, participate in this wonderful mug meeting tonight. I mean,
Right.
how much excitement can one guy get for a whole day?
Oh, yeah, it's been enough excitement for me already. I had one of the busiest days I've had in a long time, just nonstop people firing stuff at me. Sort of forgot what that was like. Ron, um, Wolf and I were looking at the emails you sent for testing for the runtime arguments thing. And the emails you sent from your Gmail account worked. We each saw them. We didn't see any of them from your D results address.
Yep.
So I'm wondering
There's
if you don't have your SPF or your DKIM stuff, probably SPF in your DNS for your domain.
I need to conduct an experiment with a change I put in to see if that solves the issue.
Normally, if you send email from an address that looks like spam, Google will get it and hide it in the spam folder for you. But this going through a email forwarder, I don't think Google's ever seeing it. I think it's stopping at the Wolf, what'd you call it? Hover.net or hover.com, something like that?
That is what I said. Hover.com.
Hover.com. Um, and I don't know if we have any troubleshooting capabilities there. We're just not seeing the mails.
Well, so for the short term, I'll use the other email account.
Well, that's a good idea if you want us to see your feedback.
I mean, heavens, I wouldn't think of just picking up the phone and calling your phone number.
All right. Or meeting us for lunch. I hate to be eating dinner right now, but I spent most of the afternoon working on my slides. I sort of thought I was all ready, but what I had was my outline from the podcast episode. Well, that is not slides.
Hey, Richard. How are you?
I'm doing good.
Good to see you.
Yes. When it becomes appropriate, I'll make an announcement, a couple of announcements for Semco.
I'm going to just turn my camera off for a minute. Let's see. That sounds like Wolf's dog.
Hello, Jim.
So I'm thinking of starting a computer club down here in Texas. Or if I'm going to get very many technical folks, these probably going to be just Windows folks that want to know how to use passwords, you know. But I'm thinking of giving it a try.
Kind of like a Semco for Texas.
Yeah, something like that. So,
All right,
Jim,
dinner is over.
yeah. So, Jim, how has attendance been at these meetings?
Oh, we get 18 to 22. It'd be nice to get 50, but we do all right.
Well, it seems to be the same 6 people talking all the time.
Yeah. Yeah.
Would you like to put on a presentation?
Yeah, it could be one of you. It could be you talking.
I think I'm gonna have to leave. My computer's acting weird.
We can see you. We can see you, Richard.
Yeah, maybe just
Yeah,
need to
I
reboot and
can't
come
see
back.
anything. All I see is black.
Well,
I'm gonna
That's
come
not
out and
good.
come
We
back
can tell
in.
you. What do you need to know? We can just tell you about your room and
Yeah.
Yeah, I'm gonna
All right. Well, hurry
come
back.
out and come back in. Yeah, I'll see you in a couple minutes.
All right.
Okay.
Hey, Gib, I saw your email about genetic testing.
Yeah. Yeah.
Is that something you're interested in doing, or just wondering if other people are doing it?
Well, I saw an ad pop up. It's one of
Ah,
these saying things, send us money, we'll tell you all
yep.
kinds of stuff. And I don't know if I'm really that interested, but I found that when I did the spit test for family check to find out family information,
Yeah.
find out some interesting things. So I thought that was worth the $50 or
Well,
whatever it was.
I did the 23andMe thing,
Yeah.
to find my fifth cousin and that kind of crap. And um, I kept getting notifications that somebody new to my family had joined, and it was like a fourth cousin. Somebody lives in Wyoming that I'd never heard of before. Fourth cousin. That's not very related. Then my 23andMe kind of, I don't know, they fell on hard times and they sold, and then like the data was going to become possibly public because the company that bought them is less than trustworthy. So I deleted my account, deleted all my data.
shouldn't by this time the ancestry of the entire, at least Western world, have been mapped out? I mean,
Well,
if one of your cousins
think of the
does,
privacy issues.
well, without regard to that, by this time,
It probably has
shouldn't
been
there,
mapped out.
yeah, hasn't it all been mapped out? I mean,
Probably.
if one of your cousins does it, then that part of your family's done. Nothing more to do. Somebody on
Well,
the other side does it. I mean, by this time, you stitch all those together, isn't it
yeah,
all done?
but a cousin represents only a fraction of your DNA. I mean,
Yeah.
just your two parents are you get 50-50 on them, and then they're made up of 50-50 of their parents. And
Oh no, I know that's that,
but
but the genealogy aspect of it, I'm just saying it ought to be mapped by now.
I don't know,
It should be all done. There's nothing more to do.
the data person that I am wants to know. You know,
Okay.
I would like to see the entire map of everybody to see how am I related to you, right?
Uh,
There's a connection in there someplace if you go far enough.
well, yeah. Back to
Neanderthal days.
Whatever. But the privacy person in me doesn't want anything to do with that. And Gib, you saw an ad for somebody that wants you to send them money, and that's pretty much what that is. They just want your money. Um, my client that does breast mammography screening for breast cancer, they do genetic testing, but it's very specific. They're looking for the BRCA genes and a couple of others, and that works really well. But their goal is to search for cancer. I think these companies that are just searching for anything, they're just in it for the money.
Yep. Okay. Thanks for the feedback.
That's my opinion, anyway.
I did Ancestry DNA and I am impressed. The more people they get to join in, the more accurate they send these emails
Sure.
saying that the results are more accurate now. And like every 6 months, it gets more and more accurate. So it's really impressive.
Yeah, well, I wanted that to happen with 23andMe, but like my daughter was on it and my nephew was on it, and that's the extent of the people I knew.
Yeah.
Everything else was third cousins and fourth cousins, and
Well, I'm speaking about the nationalities of the ancestors.
yeah, that was
You know,
interesting.
what percentage comes from what country?
Yeah, I'm 97% Northern European. But that's really interesting.
Yeah, so I had, already my sister had gone through and done a full family history thing, and we
Mhm.
had all that information. So it wasn't really that I found interesting. What I found interesting was genetically knowing which group of people out of Africa I belong to.
Sure.
The fact that I have Neanderthal DNA, something about I'm related to what is it? The queen that was beheaded in France's
Well,
been,
Mary Queen of Scots or something,
yeah, so it was
or
like,
France.
and I have a lot of French in me, and I didn't realize that. So
Well,
those types of things, those stories were kind of interesting to me.
sure, sure.
So I don't know
Yeah,
what kind of stories I might get out of this, DNA testing. They have like all kinds of rare disease screening and stuff, and
sure.
okay, if I have a rare disease and it hasn't hit me yet, that's fine. I'm just wondering maybe if we do find something that other family members might be advantaged from knowing that.
Yeah.
I'm I'm back.
Hey, Richard's back.
Had to
Oh, there you are. No,
had to shut down Windows and then I had to do an update.
Of course you did.
Windows was insisting that you reboot.
I was insisting on doing an
Yes.
update.
Actually, I decided to reboot and then it decided to do updates.
Oh, I'm running Windows 11 now and I see these pop-ups all the time. We need to install updates and your machine will reboot in 10 minutes. And then the options are okay or not now, or I think it is.
Yeah, yeah.
Yeah, I haven't had too many of those. Generally when I shut down, if there's one available, it doesn't.
I have a friend's computer today that had a nice pop-up window saying this was Windows Defender saying people, something's wrong with your computer. Call this 800-888
Oh
number.
yeah.
Oh, yeah, man. I'll tell you what, not do that.
That's a scam, yeah.
Yeah. With a phone
I
call,
don't know what
you're
to do
putting
about it.
packets on the internet.
I have no idea how to handle that. He's got a guy he bought the computer from. He's going to take it to. I don't have a clue what to do.
Sounds like it's already infected.
Yeah.
Yeah.
Time to run an antivirus and also some programs like CCleaner.
Yeah.
Yeah.
All right. What do you think? Should we get this thing started? Oh yeah, it's 6:41. Well, everybody here? Yeah, everybody's here. Oh look, Roller Angel's here. The person I'm not seeing is Joe. He usually brings along a bunch of people with him, but I don't see him. Hope everything's okay because he wasn't at the last board meeting either. Anyway, so let's get started. Welcome to the December 2025 mug meeting, the last meeting of the year. Today we've got something I think is interesting, probably because I'm presenting IPv6. But before we get into that, we're going to do a short topic. We're going to talk about open and XDG open, a couple of commands for opening applications. It's kind of neat, and I hope somebody's got a Linux box that they can demonstrate it on because I've only got a Mac here. But we'll play with that in a couple of minutes. Before we do that, let's see upcoming meetings. The only one I know for sure that's going to happen is the January meeting. Let's see, what date is that? It's January 13th. My brother is going to be presenting at that meeting. He is the manager of in-flight entertainment and Wi-Fi for JetBlue Airlines. All that stuff going on with them and doing their internet, satellite internet, and live TV and stuff. That's his baby. So he's going to be here talking about that. So that should be kind of interesting. I'll put the announcement up soon for that. I'm kind of looking forward to it because he feeds me bits of information about how it works. And occasionally when the tech stuff gets kind of deep, he starts asking me questions. Yeah, I can handle the Linux part of it because they do use Linux. But when it comes to all the satellite stuff, that's not me. Anyway, so that's going to be the January meeting. I think we've got some ideas for February and March, but nothing firm yet that we can talk about. Dave, you want to talk about membership?
Sure. Membership. We are a completely open organization, and everybody is welcome, very, very welcome to participate without being a member. That's not a requirement at all. We'd love to have everybody. We do have an opportunity, though. Of course, at one time we had some really serious expenses. We had to rent rooms to meet. We don't rent rooms anymore, so expenses are way down. But we still have an opportunity, if you would like, to become a dues-paying member. And the benefits of that are, you just sort of get the feeling of belonging to do that. And that's worth something on its own. You also get the right to vote for the committee, the board of directors, which should be coming up in April. Some of these are really hotly contested elections, and you want to be there.
Yeah, there's all kinds of election rigging and everything.
Properly getting your vote in. And if you'd like to run for the board, if you'd like a seat on the board, we probably, just talk to us. We'll get you in. We got some polls in. It's $50 a year. Well, it's $50. Since we have enough money right now for all of our expenses, as far as we can see for quite a while, memberships don't expire. At one time they were $50 a year. Now they're $50, and everybody's expiration date keeps going out every month. And if we ever decide to do anything where we need money again, we'll do something then. But go to the website and pay through PayPal. You can contact Dick Williams, who I don't see online. He's not here.
No, I don't see him either. I hope he shows up.
Become a dues-paying member if you would like. If not, just keep coming to the meetings, and we want you here no matter what.
Yes. So yeah, go to mug.org. There's a membership tab that you can click on to figure out how to become a paid up member. Otherwise, just show up. That's what we really want, right? See, any other business groups in the area? Gib, is MD Lug still there?
Yes, MD Lug, second Saturday of the month, noon. It's an online only. We have typically a half dozen people show up, and we have informal discussions and all kinds of interesting topics. And we basically, have a lot of just fun talking about loosely anything that goes on. So that'd be this coming Saturday, and the topic that'd be December 13th. We're talking about pass keys, and so it's like a whole. And Pat is like a doctor of security, and he's going to go deep dive into this pass keys. And there may also be Carl giving a demo of something called Stage Hide, STEGHIDE. Anyway, the website is mdlug.org, and you're welcome to come there. It's free. Thank you.
All right, great. Richard, you want to talk about SEMCO?
I definitely do. We are going to have a good presentation this Sunday coming up, and it will be done by John C. Maloney. He works for Comerica Bank, and he's talking about cybersecurity best practices.
Hmm.
And he will do a good presentation. Also, in January, I forget the exact date, but we are having an amazing presentation. Nathaniel Borenstein. You can look him up on Wikipedia. That's how well known he is. He is going to be doing a presentation on a future worth hoping for, artificial intelligence and human destiny. He's written a book on the subject, and he will be doing a presentation.
Hmm.
You all will want to see that presentation.
Yeah.
Don't even
I-
think about missing it, because AI is affecting everything, including Linux. And I'll bet you these servers that have that do the AI processing, I'll bet you most of them, if not all of them, are Linux. So definitely come to our meeting. And as always, we have a second presentation done by Sharant Kawani on Linux. So if you like Linux, come to Semco meetings. You can find out about it at semco.org. And if you scroll down a little bit, you'll see click here to be connected to the meeting if you want to join on Zoom. But if you want to come in person, Rochester Hills Library. And we have signs that will mention which room we're going to be in because they have different rooms. We're in different months.
Okay.
We'll be in, I believe it's room 2B this Sunday coming up. But then there's a multi-purpose room, which is right close to when you come in. And that one will be the one that will be happening in January.
Right. And they'll be online as well.
Yes, we do simultaneous in person and on Zoom. And it
Excellent.
works.
Gib, you got your
Do
hand
it
up?
right, it works.
Yes. So I was trying to figure out what that stagehand thing is, and I looked it up. It's open source stenographic program used to hide data. So files and
Ah,
so inside other harmless looking files. So like JPEG or BMP.
is it steganography?
Steganography. Yeah.
Yeah. Bill Alley gave a talk about that. Gosh, must have been 1995. Remember, remember when we used to meet at the Leather Bottle Inn in Livonia? I don't know how many people here remember that. Uh,
Yeah. I
but
remember
uh,
that.
but Bill Alley gave a talk on steganography. I think that's how you say it. It's pretty interesting stuff. So you're going to be talking about that at MD
It's
Live?
gonna be a demo.
Okay, cool.
Demo it.
Cool. It'd be interesting to see how it's come since, I mean, that's 30 years ago. Um, I'm sure there's been some advancements. I suppose you could use that for spycraft, right? Hiding stuff in other things. Um, all right, thanks. Another group is the Lansing. I don't know the URL, but Joe is always here to talk about it. The Lansing group, and I think they meet up. Gosh, it sounds like they meet up once a week or something. It's kind of crazy. Um, anyway, I think that's it for the groups. Next up, I think we're going to talk about the little Linux Unix command that we have. We're going to talk about open and XDG open. Uh, I'm on a Mac, so I can show open. I'm going to share my screen, and I'm going to share my whole screen. And you guys are probably, you're going to have to tell me if you can see it all right or not. Um, let's see, yes, that one. And that shrinks out of the way. Uh, can you guys see that all right?
I guess
Yes.
it
Pretty
is.
small, but yes.
Okay. Because you're seeing my entire screen, right?
Yes.
Anyway, there's a command on Mac OS called open, and it's kind of similar to xdg-open on Linux. And I use this all the time just for simple things. Like if I have a PDF file I want to open, let's see, I'll increase my font size in a sec. Not a PDF. I'll open API. So I'll do things like this. Let me. Does that look all right? I'll do a command like just open, and I give the PDF name, and it opens the PDF viewer for me. In Mac, it's called Preview. I can open. I'm pretty sure I can open a URL. Oh, what's a good URL? I used to always go to CNN as my example, but I don't like CNN so much anymore. But okay. It launched the browser for me just by typing open. You can also open apps, and on Linux, your apps. Well, I don't know so much if you're in GNOME or KDE, but when I was on Linux, my apps were like Xterm, and I would just type Xterm, and it would launch for me. Apps on the Mac aren't really like that. They're not in your path. They're in a directory called /applications, and they're kind of buried deep in there. But if you want to open an app, like I can open iTerm, I think I got a .app.
Okay, so it's actually called iTerm2.
Yeah, but the app is iTerm.app. The app, I'm pretty sure the app is.
I don't think when you say -a that you have to say .app.
Yeah, open -a iTerm2. I think doesn't work. I think it's iTerm is what it's called on disk. So anyway, you can't see it, but it's launching terminal. Well, in fact, it's since I've already got it open. In fact, that's what I'm using right here. What's another app I could run? Wolf, you got an idea for another app?
Marked.
I can't hear. What was that?
Marked.
Oh man,
And it might be called Marked 2.
Okay, your audio is all messed up.
Well, I'm standing up and walking around the office doing things.
It's just.
But right now I'm right in front of the mic, so I don't know why you don't hear me.
Oh no, we can hear you.
Oh, we hear you. It's
like
very,
hitting
very,
all the
very
red-
loud.
The levels.
We
are
hear
getting
you.
like-
You're overdriving the mic.
Yeah.
Yeah. Are you excited?
No,
Let's
he's
see,
muted.
marked. Oh, you know what it is? Marked is, watch this. It's marked 2. And I don't know what it's doing. I'm not seeing it. Anyway, you can launch an app that way. I think you can launch a new instance of the app with an N. Anyway, yeah, it actually is launching, but it doesn't open a file yet. Oh, you know what I can do? If I have an let's see, open -a. Can I do this? Helix editor. Yeah. See that? I opened the marked application and it launched with that file name. So this is how you run commands from the command line to open apps. You can. I could have just opened Helix without specifying the app I want to use, and let's see what app it actually. Let's do that. It just opened the Helix editor with it opened the MD file using the Helix editor. That's kind of interesting. So somewhere along the way, Helix must have registered itself as the editor for Markdown files. Maybe? I don't know. No, it actually opened Xcode to edit the Markdown file. Anyway, the counterpart to that, like I said, is XDG open. Does anybody here have a Linux desktop open that they're running?
Yes.
And you should be able to do. Let's see. I don't have a Linux desktop around here to play with
Yes,
this.
I have one. Trying to figure out how do I
Hey,
share.
there's Mr. Williams.
Hello? Can you hear me now?
Yeah, I hear you.
Yep, we can hear you.
Okay, so I'm trying to find the thing that says share. Oh, there's share. Okay, share. Let's see, screen one here. Are you seeing my screen now?
I see it. Maybe increase
Okay.
your font size.
Yeah, how do I do that? I just do
Try.
control.
I don't know what you do. Control plus, Alt plus. On
No.
Or try
No.
Control Shift plus.
Control Shift plus. I don't know.
There you go.
Yeah, that's working.
Okay,
There you
so I had a bunch of commands up, but somehow I did something different that switched me to a different version of what. Oh, see, there it is. All right, so that command, I was just looking at that a moment ago, the
Yeah.
XDP whatever,
Yeah, just do a quick man page on it.
XDG open, right?
Yeah.
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 Okay,
Opens
yeah.
a file or URL. Using the
Okay,
preferred
so you
application.
should be able to just go and do that then, right? So
Yeah, so if you have a PDF or a HTML or anything.
okay, so let's try this. So the first one I do is www.
You need a space there.
Okay, I didn't type a space. XDG open.
Oh, try HTTPS. Put the HTTPS://
Okay, so that
There you
works.
go. Yeah.
Oh.
So it opens that using your
Almost there.
preferred browser
Yeah,
or your default browser.
and
neat.
do let's try.
Yeah, wget or curl, they're just going to suck the file off the internet and save it for you.
Yeah. Okay, so let's do index.
You might need to rename it to take the .1 off the file. Oh, that worked.
Yeah,
Competent.
Yeah.
not as pretty
Yeah.
as it was with the other one. I don't know if there's some kind of formatting that isn't set up.
Well, when you use wget, all you grabbed was the home screen. You didn't grab all
Yeah.
the artifacts that go with it,
Yeah. Okay. All right.
Um,
So yes, it
styles
works.
and all that stuff.
Yep.
So yeah, do you have a PDF file you can open? Because it's going to open. What are you in GNOME here?
So I don't have any
Okay.
files. This is like
But I would
Well-
assume you could type open xddg open space some PDF file and it would launch the PDF reader.
yeah.
Events, is that what they're still using these days?
Yes, it does.
Yeah. So I don't have any files on this system.
Okay. All right. But that's the open and the xdg open commands. Anybody have any questions or anything they want to add to that?
I did a Google search using the AI mode, and it told me also how to query what is the application that would open with a specific file name
Yeah.
or type, and then also how to set it if you want to change it to something
cool.
different. Yeah.
Do you want to share your screen and show that or
Okay, sure, yeah.
yeah.
Oh, it says, let's see. The host isn't allowing multiple presenters sharing for this
Oh,
meeting.
Gib,
Do
you
I
need
have to
to,
stop sharing? Is that what that's
yeah, you
telling?
need to, yeah.
Okay, now let me try.
Okay, I've stopped sharing now.
Okay.
All right.
All right, now share. Let's see.
Oh, one more reason to dump Mac.
Why is that?
Oh, you were running that under Linux.
Yeah.
And,
Yeah, but Mac
Okay.
has open, does the same thing.
So I asked how to set default applications for XDG
Yeah.
open. And what you do is you can say, let me enlarge it a little bit here.
Oh,
Oh,
okay. So there's an XDG. Oh, yeah.
Didn't enlarge.
XDG, that's the X
Oh, there it
desktop
goes.
group, right? It used to kind of be part of
Yeah.
X Windows, but like an add-on to X Windows. But
Yeah.
it kind of became a thing on its own. And I think it came out of the free desktop group. Um, there's all kinds of commands that start with XDG on Linux.
So here's an example, xdg-mime query. And then
Okay.
you're looking for the file type associated with my document.pdf. So I did try this earlier and it does indeed return application/PDF for me.
Okay.
And then once you do that, you can also, let's see what else here, set the default application or let's see, a
How,
default.
yeah. How do you query? How do you see what the
Yeah,
default app is?
I think, let me try here. Can everybody see my terminal?
Yeah.
I'm using fish, which the fish shell, which has an open command, and all it is a simple fish script, which ultimately executes XDG open.
Okay.
So I can say open or XDG open on here.
Oh, I see.
And let's see now if I
Yeah.
do XDG mime help. Here we go. I had it. Fish is remembering my last XDG mime
Sure.
command, querying the default application for application
Okay.
PDF, and it says it would open it with Chrome.
Oh, it'll open on the Chrome browser.
Yeah.
Interesting.
And then I could set
But
it
you
if
could change it. Yeah.
I can. Yes, I can change it using xmime. Let's see what is how to change it. Query default. That's what I just did. Oh, and then there's this special one, the default web browser.
Oh, yeah.
I'll try that one. XGG.
And you could set the default, like you could change it to Firefox or something.
Yeah. Get default web browser, and it tells me it's Firefox.
Oh, okay.
Yep.
Hmm.
And I think I have to set it. I think I did XGG my help. So
Yeah, I don't know.
let's see here. XGG.
Maybe it's XDG MIME default, um, the name of the app, and then the file types or the MIME types.
No, there's one here where I don't think I set it. I think I just was querying. So yeah, I don't have that on there.
So do a query for file type or MIME type. What is it? Text/plain? What is what is it? Text document? Yeah. Okay. Plain. Yeah. Okay. So it opens that. You could change it to like use Vim instead, right?
Yeah.
Or whatever I don't know. There's some graphic editor probably in GNOME. That's neat. Do that again though, where you did the query, um, and you just said text, and it listed all the text. Yeah, like just take
Oh
off
yeah.
PDF, Take off.
Okay.
Yeah. Take off.
That's
Just text.
yeah, that's using a
Or was
feature
that?
of readline or no, the fish
Oh, was that
shell.
doing shell completion?
Yeah.
Okay. Cool. Wow.
Let's see here if I do it again.
Yeah. So look at all
No.
those apps, all the different apps you have for the different types of text files.
Yeah.
Yeah. Thunderbird,
Wow, there's a whole bunch of them.
VLC. Yeah. Huh. Micro.desktop, and Vim.desktop, or Vim. I guess it tries them in order.
Oh, I guess it's even showing what they are without even
Yeah,
running
that's
the,
what I was looking at.
yeah. So
Yeah, I'm guessing it'll try those in order.
this is all due to fish, the fish shell.
Okay. Neat.
Which the fish has a lot of niceties
Yeah.
for interactive use.
Hmm.
Okay, I'll stop sharing here.
All right. Well, thank you. Anybody else have any questions or comments or anything before we move on? You all good? Okay, good. Oh, let's see. All right. Well, let's get on to the big presentation. Let me close up my screens here, bring up some other ones in. I'm going to do this. Let's see if I share. I want to get my whole. No, I want to get that desktop. Share, and then this thing shrinks. And is that looking okay? I have no way of seeing what you're seeing.
Yeah.
Yeah. Yeah, there we go.
V6 size really matters.
Oh, what's that? Yeah. Yeah. This talk came out of a podcast episode that Wolf and I did, like, I don't know, 2 months ago about IPv6. And it started because I got interested in IPv6 because I bought a new router for my house. I wanted something with a few more features than whatever Xfinity gave me. I wanted to be able to do VPNs and all that kind of stuff. And the Xfinity router is really basic. So you guys remember Marlon Dutra? He's the guy that works at Facebook. He's a network engineer at Facebook. He suggested I get the Netgear 1100. I forget, Netgear something 1100. Anyway, it's a nice little router. It's like $170, and he suggested I get that. It runs pfSense, which I didn't know anything about, but I was really, really impressed with it when I got it. So then, I'm not a network guy. So when I need help, I call Marlon because he's one of the guys that keeps the Facebook network running. So I called him and he helped me through setting the whole thing up. And he said something that really stuck with me, and that is, make sure you enable the firewall. Well, it's enabled by default. So make sure you keep the firewall enabled because you're running IPv6 in your network. And I'm like, what? Okay, so I'm running IPv6. It wasn't really a surprise to me because when you look at your network interfaces, you see an IPv6 address. But the thing that surprised me was he was telling me that I need to have it turned on. And when I pushed him for why, he said, because IPv6 doesn't use NAT. And a lot of people think that NAT is all the firewall they need. NAT will give them protection from the outside world. Because you can't, if you have a desktop inside and you got a router that's doing NAT, your desktop inside the network can reach the outside world, but the outside world can't reach your desktop because of IPv4 and NAT. Well, if you got IPv6 enabled, guess what? That's a public IP address. The IPv6 address you have on your desktop is public. So that sort of was an eye-opener for me. I would have had the network. The firewall comes enabled by default, and I would always keep it enabled. But just learning that little tidbit of information was kind of important. So
every device on your local network has a public IP address on IP6. Did I understand that correctly?
Yeah, Yeah, if it's got an IPv6 address, it's likely got a public address. Okay, so we'll get into some of that. I put together some slides. Now this was a podcast episode, and when we did the podcast episode, there's no visuals; it's just audio only. So I thought that this talk was going to be pretty simple, and I wouldn't have very many slides. Well, I ended up with like 24 slides when I got all done putting all the information in. But some of them are really simple, like this one. IPv6 is not scary. There's some new commands and some changes to existing commands, but it's pretty cool. A little history of networking. Really, since the invention of the telephone, we've had this thing called a circuit switch network. And you've all probably seen pictures of the telephone operator connecting phone calls. This is long before SS7, automatic network switching and stuff, or automatic call switching. The telephone operator would actually connect your phone through a series of telephone operators to the destination phone, and that's how you talked. You had basically a wire going from your house to somebody else's place, and that circuit was up and it stayed up for the duration of the call. It was one clear path all the way. For all kinds of reasons, the Department of Defense wanted something better than that. They wanted something resilient to problems. So they created the ARPANET back in the 60s, and they were using packet switching network, packet switched networking. And that is packets fly around the network, and there's routers in the middle, and the router takes care of figuring out where the next hop is for the packet until it gets to the destination. Instead of the data being one continuous stream on a dedicated connection, they were just these packets floating all over the place. And a lot of times packets didn't necessarily all go the same way. Your data was broken up into smaller bite-sized chunks, and one packet might go one way and another packet might go a different way, and they'll end up at the other end. That's kind of the beauty, I guess, of packet switched networking. The other thing is, if there were a problem, for instance, this was back in the Cold War, if there'd been a nuclear explosion and it took out part of the switching that was taking place, the packets would just automatically reroute. Usually in milliseconds, they could reroute. So it was a kind of a redundant communication method that the Department of Defense wanted. In 1983, ARPANET started using IPv4. And IPv4 is what we've all been using since we've been on the internet, right? I mean, everybody here it probably is using IPv4 and has used it. And most of you guys probably understand it. Several of you, I'm sure, understand it way better than I do. But it's basically a 32-bit address expressed in a dotted quad format. 4 octates separated by a dot. You see my example there, 192.168.0.1. You've all seen those addresses, right? So maximum of 2 to the 32nd power of addresses. So it's like almost 4.3 billion addresses, billion unique addresses. But large blocks of those addresses are unavailable for us to use because they're reserved for things. Somewhere here I do have here's the things that they're reserved for. Like the 10 network is 16 million hosts. The 127 network is 16 million hosts. Several others. The 192.168 is 65,536 hosts. Those are not allocatable by IANA. So there's probably 50 million addresses or more that can't be allocated for public use because they're reserved. So really, we don't have 4.3 million addresses. We have something less than that. Anyway, back to you. With IPv4, we had something called classful addressing. The class A was you took the 32 bits and you say the first 8 bits is the network, and the last 24 bits is the host within that network. So you see in my chart there, that's 128 networks, 16 million hosts. There weren't very many of those allocated. Class A's. It's for very, very large organizations. There are some organizations out there that have a Class A, but there's not that many of them because there's only a maximum 128 that could have been allocated, and there's a lot of those that are reserved. You couldn't allocate 0.0.0.0. You couldn't allocate 255. The rest. You couldn't allocate 224 because that's multicast. 192.168 you couldn't allocate. So the Class A's, there's not really 128 networks. Class B, there's 65,000 networks with 65,000 hosts on each network, and Class C is 24 bits. That's 16 million networks and 256 hosts on each one. That's for small organizations. So we're running into the IP address exhaustion. You guys have been hearing this for years, right? We're running out of IP addresses. It's hard to believe that 4 billion isn't enough, but if you consider there's over 6 billion people on the planet connected to the internet, well, 4.3 billion addresses is not enough. There's over 18 billion cell phones in use in the world right now. And each of them, well, maybe not the flip phones, but most of those cell phones are on the internet. Between 17 and 31 billion IoT devices that are on the internet, and they estimate 40 billion by the mid 2030s. So you've been hearing years that we're going to run out, right? There's two reasons we haven't run out, or sort of haven't run out. They went to classless routing. Remember that routing, the classful addressing that I showed you, that slide? The Class A, Class B, and Class C. They stopped doing that because it was incredibly wasteful. If we go back to that slide right here, if somebody gets allocated a Class A address, they can have up to 16 million hosts on that network. But come on, how many companies or organizations that had a Class A actually had 16 million hosts, right? Maybe AT&T has a Class A. I suppose they could have 16 million hosts because of the phones and stuff. But probably Ford Motor Company and General Motors, they might have had Class A's. They did not have 16 million hosts on their network. Even a Class B is pretty wasteful. For a large organization, how many companies had 65,000 machines on their network? So there's a lot of wasted addresses. Even a Class C, a lot of companies had Class Cs. A company I used to work for back in the 80s and 90s, we had a Class C, and we had 256 addresses, but I don't think we ever had more than about 8 or 9 machines on that network. So a large part of that address space was just wasted. So you can see how we could easily run out. So they went to this classless routing, and your IP address would be that dotted quad notation with a slash, and then how many bits are for the network, and then how many bits are for the host. When I had a rack in a data center down in Southfield, I had a /28 address. That gave me 16 addresses. That's all that I had to play with. And really, it was only 14 addresses because the 0 and the 15, because 16 is 0 through 15, right? I couldn't use the 0 because that addresses the entire network. And I couldn't use 15 because that's the broadcast address for the whole network. So I really only had 14 public IP addresses that I could use. So they gave me a /28, gave me 16 addresses, and they could have given lots of other clients /28s. So now a Class C would have been broken up by many clients, and each of us would have had 16 machines. And it turned out that was a pretty good size for me. At various times, I might have had like 10 or 11 public machines on the public internet. So I was utilizing that /28 pretty well. So you can see how a Class A or a Class C could be divvied up further into a whole bunch of clients. So that worked out pretty well. So That's one of the reasons why they didn't really run out of IPv4 addresses as quickly as people thought they would. The other way is NAT. You guys are all probably doing NAT in your homes, right? Network address translation. You don't have public IP addresses for all of your machines, but all your machines can get out to the outside world. That's because the router or the firewall is translating your internal address to your public address, and that's how it's talking to the outside world. And then the return packets come back, and your router will translate them back to your internal address so that it hits your internal machine. There's a NAT table in your firewall, and it takes care of all that. So that's another reason why we did not run out of IPv4 addresses. But eventually we did. February 3rd, 2011, IANA actually ran out of IP addresses that they could allocate. There were no more blocks of addresses that they could give out. So people were, subnetting their blocks that they already had. Things like that. And IPv6 came along to help the problem. IPv6 to the rescue. But when I talk about IPv6, a lot of people say, well, what happened to IPv5? Well, it turns out IPv5 existed. It was the Internet Stream Protocol. It's experimental, never released to the public. It really has nothing to do with IPv4 or IPv6. It's not like a halfway point between the two. If you look at an IP header, like if you take Wireshark or TCP dump and you examine the packets as they're flowing through your network, you'll see, I think it's the first couple of bits in the IP header are the type, and you'll see binary 4 for IPv4 and binary 6 for IPv6. So really, there is no IPv5. IPv6, what does it give you? Lots of cool things. 128-bit addresses instead of 32. So that's a much, much larger address space, right? 340 undecillion unique addresses. Have you ever heard that number before? It's 2 to the 128th. If you write it out, you see that big long number I have there? That's how many addresses IPv6 allows, unique addresses. That's 340 trillion. Yeah, there's 340 followed by 36 zeros. A lot of people talk about various statistics about that. There's enough addresses for every grain of sand on Earth and still have plenty left over. Or you could assign a unique address to every atom in the human body and every star in the observable universe and still have enough addresses left over to create new galaxies. That's a lot of addresses. Any questions so far? Anybody still here?
Yeah, it's a big topic. I'm writing up some recommendations in the chat of stuff.
You know what? When I'm doing this, I can't see the chat, which is really annoying. Anyway, where did I go? So addresses are represented in 8 groups of 4 hexadecimal digits. It's 8 quads separated by colons. Each quad is separated by a colon. So there's my example address, 2001:0DB8, blah, 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 right? That big long number. There's a few tricks that you can use to shorten that. Leading zeros can be removed for any of those quads. And the longest set of quads where each is all zeros can be removed. And you see the bottom there of my example. We shortened that quite a bit, right? We took out the leading zeros and the long string of zeros, we replaced it with just colon. So that would expand out to the address above. It's the same thing. So it's better. Still not an address that you really want to type in, right? Another example of shortening. Your local host in IPv4, your local host address is 127.0.0.1. In IPv6, it's ::1. If you stretch it out and show its real representation, it's all those zeros separated by colons with a 1 at the end. So it's localhost is really nice. All right. So let's get into what you can do with this. If you want to see your IP addresses, I'm going to open a window and bring it over here. Let's see. I'm going to make that bigger. Can you guys see that all right? Let's see, I'm on a Mac, so I'll show what Mac shows first. And if you're on a Mac, if you ever look at your IP addresses, your interfaces, you're going to know you have a lot of interfaces. And that's because Mac
Can you make
creates
that
an
one size
interface.
bigger?
Sure. How's that?
That's much better.
Okay. I was just pointing out that when I run ifconfig, I get a ton of interfaces. That's because on a Mac, they create an interface for everything. You know, there's an interface between my Mac and my phone. There's another interface between my Mac and my watch. And then there's an interface. I got a couple of HomePods around here. There's interfaces for each of those. It's kind of nuts, and kind of wish they didn't do that. I've got a couple of VPNs connected right now. Those are interfaces. I've got Docker running. There's a couple of interfaces there. Anyway, the ifconfig command is how we look at it on a Mac. I'm going to do the same thing on Linux. Let me increase the font. Let's see. I have testnet. Let's see. .local. Yeah, there we go. On Linux, it's the IP adder command. See, that'll list my interfaces. So I've only got two interfaces on this machine. I've got the loopback interface, the localhost, and the ENX0 interface. But you can see, like my ENX, this is my Ethernet interface. Maybe I'll make it even bigger because it's showing a lot of information. It's showing my IPv4 address. And it's also showing a bunch of IPv6 addresses, like this one, and this one, and this one, and this one. I've got, how many have I got? 4 IPv6 addresses. If I do, let's see, I can do -6. IP-6 adder shows me just the IPv6 addresses. So that kind of cleans it up a little bit. And on Mac, I can do ifconfig -a inet.
Jim, do you know why you have so many IPv6 addresses?
Yeah, I'll get into that in just a second.
Okay, sure.
So I can see just my IPv6 addresses in Mac by using the ifconfig -a inet6. You can also do it in Windows. For those of you who are on Windows, you can do ipconfig/all to get all your addresses. Or if you're running PowerShell, you can run this goofy command, the getnet IP address -address family IPv6, and it'll show you all your IPv6 addresses. Let's see. Here, like here on my Mac, actually, let's do this. I can do ifconfig EN0 is my main Ethernet interface. And look at that. I've got all these addresses. Some of them are special, but if you see this one, let's do this again. Let's see, what was the way to get it? -a inet6. -a. What am I doing wrong there? Oh, I guess when I do that, I can't list, maybe I can't, EN0. No, when I do -a, I can't give
Can you
it
put a -i on before EN0 for interface?
No.
No, that's on Linux.
But that's all right. We'll do it without the -6. That's all. Okay. Well, no, it doesn't even like that. Let me get rid of the -i. Okay. If I grep INET6, it gives me a nicer list of addresses. Okay. So here, we're going to talk a little bit about each of these addresses. I think I got a slide on that. I'm going to go out of, yeah, here we go. So these different addresses, if you look at mine on my desktop here, I've got an FE80 address. Okay, that's my link local address. That's an address I can use. Like all the machines on my physical network here have a link local address that's going to start with FE80. And any other machine on this same network is going to have an address, and I can talk directly to it. FD, this FD47 one, really it's the FD. If it starts with FD, it's a unique local address. And the difference between the two is the FE one is all on the same wire. That address is unique on that. I can't jump across the network through a router to talk to another machine using this address. I can do that with this address. So every machine on my network that talks IPv6 is going to have both of these. One so I can talk to other machines on the same network, and the other so I can talk to other machines on other networks. Okay. And then I got a bunch of addresses with this 2601. Now it's actually this much. Okay. If you have IPv6 from your internet provider, like in my case, it's Xfinity. They're going to give you the first half of the address. The first 64 bits are going to come from them. And what's neat is this address here is the prefix that Xfinity gave me. And if my next door neighbor is on Xfinity, they're going to have an address similar to this, but it's not going to be the same 64 bits. It's going to be the same first 40. The same first 20 bits. First 20 bits of the address for all my neighbors around here are going to be the same. It's like 26014, I think, is 20 bits. The rest of it identifies my network, my house, amongst Xfinity. So this is my network. This is my address of my machine within the network. So the first 64 bits are the prefix for the network. The last 64 bits are the host within the network. So why do you suppose I have so many of these? Right, I've got, 7 of these addresses? A key word here is, you see that? Deprecated. What that is that address, this is a privacy feature. My public address for each of my machines is going to change roughly every day. So if I use an address and I go out and I talk to the internet with that address, I'm only going to have that address for 24 hours. And at the end of the 24 hours, I'm going to mark it deprecated and I'm going to get a new address. And it's for privacy, so that if somebody gets a hold of that address, it's only good for 24 hours. They can't contact me on that address next week. It's a privacy thing. Now, hopefully, I've got a firewall blocking them anyway. So even if they did have that address, they couldn't get to it. But you see, I've got 6 deprecated addresses, right? 1, 2. I've got 4 deprecated addresses. I've got, let's see. I don't remember the difference between this one and this one and this one. This one here is my current address. If I talk to the outside world, I'm going to be talking using this address. I'm not going to use these 4 because they're deprecated, and I don't remember why this one is here and this one. I don't remember what the difference is with those. Anyway, do you guys have IPv6? Does your service provider give you IPv6? Because I know, like Ron, you're on WoW, aren't you? And I think they don't give you IPv6. And Wolf is on a fiber provider, and they're not giving him IPv6. But if you're on Comcast, you definitely have it. If you're on AT&T, you almost certainly have it.
Yeah, I'm on AT&T, and I do have it.
Yeah. Roller, have you got IPv6?
I used to. I switched to a fiber, and they don't have it. So there is a tunnel broker with Hurricane Electric that you can
Yeah.
get it back.
Yeah, there is a way to do it. Starlink is supposed to have it. I've heard that they have it. I haven't actually noticed it myself because I don't use Starlink.
Yeah,
But anyway.
I switched from cable to fiber because I got the 8 gigabit fiber.
Oh,
and
yeah?
was like, oh my gosh,
Yeah.
this is
Yeah.
a
Yeah,
data
it's
center at the
fast.
house.
Yeah, but you probably also also have carrier grade NAT, which is tricky for a lot of things. Like you can't open up a port on your firewall to host a service inside because it's carrier grade NAT. Like Starlink uses carrier grade NAT for their IPv4 network, but for IPv6 it should go all the way through. Anyway. I jumped a couple of slides. Okay, so how do you see your public IP address? There's a couple of ways. Let me slide my browser in here. You can go to HTTPS. What is my IP address? Oh, what is that?
Check out that test IPv6.
Yeah, I know that's really cool. That is really helpful for me when I was doing this.
That'll tell you your IP address too.
Yeah. So here you go to what is my IP address, and it'll tell you both of them. You see this one? I'm gonna increase the ads get in the way if I increase too much. Oh, stop it! Anybody want a rib roast? Anyway, the problem with what is my IP address is they're all about selling ads. But anyway, you can see my IPv6 address is that. And if you looked at this, it matches, doesn't it? So when I connect to what is my IP address, they're seeing my desktop address. That's an address on my desktop. That's what they're seeing there, right? If I look at my IPv4 address, my IPv4 address is a private address, 192.168, but they're seeing my public IP address because I'm natted through my firewall for IPv4. But like Roller said, check out test.ipv6.com. That one's pretty cool. I urge you all to go give that one a try, test-ipv6.com. It'll tell you if you've got IPv6. And this one is also showing me, this one doesn't have a bunch of ads, which is kind of nice. It's showing me my public IPv4 address, and it's showing me my desktop's IPv6 address. If I went to another, like if I fired up my laptop right now and I ran it, I went to test IPv6, it would show me the same IPv4 address, but it would show me a different IPv6 address because my laptop's going to have a different address than my desktop does. It knows who my service provider is. That's because of that first that prefix, it's actually the first 20 bits of the address identifies it as Comcast. And then there's a tab for the tests that it ran and other IPv6 sites. You can go there to look at things. Anyway, it says I got a score of 10 out of 10. So my IPv6 is good. So I'm happy with that. From the command line, you can also do it. Curl ifconfig.me. See, it gives me, it's showing me my my IPv6 address at the command line.
Right.
If I didn't
that's
have,
a good. I was gonna say that's
what's
a
that?
good point. It's a good point to mention that most commands will have a IPv6 version or
Some
option.
of them do, yeah. Like curl doesn't need it. Curl is just awesome. But there are some other commands like, let's get to that. Here. Ping 6 is one of them. I think there's a traceroute 6 and a couple of others that have 6 appended to the name. But we'll get back to that slide in a sec. Okay, so that's how you get your public IP address. Hopefully some of you guys have done that too. I already talked about the types of addresses. How do the addresses get assigned? Let's go back and look at my addresses again. How did these addresses get assigned? Well, the FE80, my link local address, that got assigned from my machine created it itself. My desktop created that address itself. And then it does a conflict resolution thing to make sure nobody else on the network has that. But really, let's face it, with, I don't know, what is that, 108 addresses or something, 108 bits of network address or a host address, there's not going to be a collision. The FD47 is likely handed out by the router. In fact, it's interesting. My FD47 is deprecated as well. I don't know why. I don't have another FD47. It wasn't deprecated earlier, was it? No, it wasn't. This is an earlier run on it. So maybe if I run it again, yeah, I think I got a new FD47 address. No, it's the same. It's just not deprecated anymore. Anyway, these addresses here, my router gave me the first 64 bits, and it's likely that my desktop generated its own trailing 64 bits. But you can use DHCP. It's actually DHCP v6 or SLAAC, the stateless address auto configuration. So there's a couple of ways you can get an IP address. If you've got IPv6 in your network, chances are you're just automatically getting addresses. You certainly don't have to manually assign them. Yeah. You can do address lookups. Like if I want to look up an address like Google's, I can use Dig to look up their address. And that's Google's address. Let's see. That's Google's address. It's kind of funny, you know, if you Google Facebook, or if you dig Facebook's address. Interesting. I'm not even getting an address. Did I spell it wrong? Oh, .com. Look what's in their address. Buried within their 128-bit address is the word Facebook. I thought that was kind of cool. If you want to ping a site, you can ping 6. Let's see if we can ping facebook.com. I can, and you just use ping 6 instead of ping if you want to ping an address. Oh, you want to see all the nodes in your network? There's some tools for that too. On Mac OS, NDP-A. Watch this. These are all the nodes in my network. It's just going out and it's doing a multicast thing to go out and ask for all the machines on the network. And there's a bunch of them. I've got like 70 nodes on my network. So there's a whole bunch of them. If I were on Linux, I can do IP-6 neighbor, HBOR. And it's got a smaller set of addresses. I think this is just its cache of addresses. I think if a machine contacts it, it'll add it to the cache. A lot of these are stale. There's like only one that's not. And if you look at it, it's my desktop is the only one that's not. Even the router says it's stale. Interesting. So that's how you see machines on your network that you can talk to. Look at this. My NDP command is still running. I've got Apple TVs. I got a home theater. I got all kinds of crap with IP addresses. Compatibility, like Roller was talking, Hurricane Electric has this tunneling thing. I don't know if they're using like Teredo or what, but there's 6-to-4 tunneling. That's kind of discontinued. You can route IP. You can run IPv6 packets over IPv4. NAT64 is a way to do NAT with IPv6 over, to talk to an IPv4 server. Because let's face it, not every machine on the network, not every server out there on the network is IPv6. So if you only had IPv6, you're going to have a hard time talking to an IPv4 only machine. So NAT64 is kind of a way around that. And then Teredo tunneling, that's from Microsoft. It requires relays. It's Windows only, but Miredo is the Linux Mac version of that. Adoption. Google says that 48% of their traffic is IPv6. It's growing fast. That was in 2024. 4 years ago, it was 30%. So it grew quite a bit. Facebook, 60% of their traffic back in 2023 was IPv6. 55% of all U.S. traffic. The surprising one is France. 85% or more of their traffic is IPv6. And then other countries.
One thing
Russia,
to keep
not so much.
One thing to keep in mind too is a lot of people are behind services like Cloudflare and different things like that will do all that for you.
Yeah. Well, I mean, servers are behind Cloudflare. So the server,
right?
So Cloudflare is basically proxying your requests. So you might hit Cloudflare with an IPv6 address, and then they're going to turn around and talk to the server behind it with whatever.
Right. Which so when you're thinking about adoption, a lot of people didn't even have to adopt; they kind of just inherited.
Yeah, because they're on the Cloudflare, or probably the what's the other one? Akamai. Aren't they in that business too?
Right.
Yeah. So they might be getting IPv6 for free. I provide a service on the network for my clients, and it's currently not IPv6. My clients aren't asking for it, but one of these days I'm going to get around to setting it up. I'm using Azure as my cloud service, and they do IPv6. One of these days I'll get around to setting up an IPv6 address.
Yeah, with IPv4 address getting more expensive, it incentivizes those guys to use IPv6.
Yeah. Anyway, a lot of ISPs do not support IPv6 yet, like we talked about. WoW doesn't, and like Roller's fiber. Who's your fiber company?
Quantum.
Quantum,
which
okay. So
which is
they're
funny.
not doing it?
They're ran by CenturyLink. I guess they just rebranded their fiber as Quantum Fiber, but it's just funny because CenturyLink got like blown away by cable companies stealing all their customers, and now they're doing it right. They're stealing them right back, but they didn't want people to think they were going back to CenturyLink probably, so they were like, "If we're Quantum Fiber,"
So they rebranded. Yeah.
Yeah, and then
Yeah, they're giving you
Well,
8 gigabit. Is
yeah,
that?
which cable can't even come close to.
Oh, right, right. Is that upload and download or just download?
Yes, the upload. It's crazy.
Wow,
I know.
wow.
It's like excuse me? Hold on a second.
Yeah,
I had to buy like all new networking gear because the best part about it is you know how we see like quality of service or you try and limit
yeah,
devices on your network so they don't steal all your bandwidth.
right.
Well, now devices on your network can't steal all your
No,
bandwidth
because they could. There's no way they can keep up with that.
because they can't run that fast.
Yeah, right,
So
right.
it just kind of automatically made it nice. They all play
That's
nice,
pretty good.
but if you want one of them to steal it all, you gotta go buy some new gear. And the problem with the new gear is it's the same way with the motherboards and the CPUs,
Sure.
right? Like you finally buy the latest one, and then you realize every month there's a new firmware update that's really necessary.
Yeah, yeah,
because
yeah.
it's buggy, it's being developed,
Sure, sure. It's bleeding edge.
Yeah.
Okay, so what else makes IPv6 better? It's more efficient routing. The routing tables work better. Don't really know why, but they do. There's no broadcast addresses. There's multicast for doing things like router discovery and several of those things. Uh, Packets are not fragmented. At least they're not fragmented across the network by the routers. The routers are not fragmenting your packets. When you make a connection to another machine on the other end, there's this little handshake thing that goes on that basically interrogates the entire path to see what the largest block size or packet size can be between you and that remote end, and then your machine is responsible for breaking the data stream into packets of that size. So there's no goofy breaking up of packets halfway through the link. It's you and the other side have basically agreed what size packets you want, and the whole network from here to there will support that. So that's better because fragmentation can cause all kinds of weird problems, and there's no need for NAT. We all have a unique IP address for every machine on the network. You don't have to NAT at your firewall, which is great for things like VPNs, for gaming, for voice, video conferencing. Those things can be really troublesome when you have to traverse a NAT network. It's just nice to have a direct connection all the way through. So, questions? Anybody?
When you were talking about fragmenting, one discussion that comes up with the fragmenting is the IPv6 uses a lot of ping. Not the ping we're all familiar with, but they use just different ways of, there's different modules with ping.
Yeah.
And
well, you mean the ICMP packets?
Yeah, sorry, I mean ICMP. Yeah, they use a bunch of different types, and IPv6 relies on some of those types to do that discovery. And unfortunately, there's big networks out there that have a long time ago just blocked ICMP completely, and there's this big old war. You really got to like get a hold of people at some of these networks and say, hey guys, like
you got to wring their neck.
Yeah, you can't just block all of it, all right? Like
somebody told them that ICMP is a security issue, and it's not. It's really, really important to the health of the internet to not block ICMP, because that's what's used for path discovery and fragmentation and all that kind of stuff. ICMP packets, and if you block it, you're breaking things. Yeah. More questions? Anything you guys want me to show you?
I mean, I guess where I kind of left off. Oh, sorry. Go ahead.
I was going to say, I've always been dark cloud IPv6. We're not running out of addresses. I'm sorry I got here late. I always wondered about the privacy. If I was like a pirate downloading torrents and stuff, am I more identifiable by the FBI with this stuff? It seems like IPv4, I'm a little bit more hidden, but with 6, boy, exactly. You got my fingerprint. It seems like.
Well, even IPv4, you can trace it all the way to your house. Does it matter to you which machine inside your house? You know, if the FBI is looking at your traffic, they can trace IPv4 and IPv6 equally.
So I guess I was,
because
if there was any other conspiracy theory people out there.
Sure.
Right. So you should come to the MD Lug meeting. We have a guy there who is a security specialist, and he talks about a thing called Tor, things like that. So he'll go in
right. Use
to
Tor
that question.
or one of those VPN services that are out there that will anonymize your traffic. So
right.
then
And so we've done presentations. So we've had presentations at MD Lug about this. The IPv6 thing is just a side issue with the whole question about how do you hide yourself and present yourself when it's safe.
I guess I'm not really coming at it from the hide yourself because of course there are torrent VPNs out there. It just makes me feel weird with all those extra numbers on my machine.
Yeah. Well, it's just a longer address in that sense. They can track you just as well with IPv4. Now, one of the things initially IPv6 addresses, the thought was they were going to encode your MAC address within that address, and that's how it started. 128 bits is plenty of room to fit the MAC address. What is the MAC address? 48 bits. It's easy to include your MAC address within your IPv6 address, but they were worried about privacy because now you could track it right to a machine, and that machine would always have that IP address for as long as it had that interface card in it. It was going to have that IP address, and maybe it's not such a big deal for home stuff, but if you're traveling with your laptop and it's always got the same IP address, or at least the same, if you're traveling, you're not going to have the same first 64 bits, but you're going to have the same last 64 bits if it's based on your MAC address.
Right.
So they can start tracking.
The host bits would stay the same. The network bits would change, but
exactly. But even the host bits is good enough to figure out, who you are.
Yeah. Well, I wonder at some point, we're talking about DNA and all that stuff. At some point, your DNA will be part of your address. Make it unique to you.
And I guess the other question is, in the real world, is it really that much faster than IPv4? I mean, I'm all IPv4 here in my house.
Yeah.
Is it worth my time to figure out how to get IPv6 everywhere and expect?
You know what? At this point, if it's certainly not required, but I wouldn't even say 5 years from now it's going to be required, but long term, eventually it's the only thing that's going to be there.
I guess I laugh every time somebody says that.
It's IPv4 is not going away anytime soon. There's way too many devices on the internet that are talking IPv4. But if you're doing gaming, which I'm not, but if you are doing gaming or you're doing VoIP or you're trying to use a VPN, especially something like Tailscale, they jump through hoops to get through NAT on firewalls. They got all kinds of cool tricks to do it, but they really have to jump through some hoops to make that work. And carrier grade NAT is even harder, but somehow they know the magic things to do. But with IPv6, they don't have to worry about any of that.
I do the VoIP and I do the video conferencing. I'm not a gamer, so if I was a gamer,
if you're a gamer, I don't know what it takes to do gaming on the internet.
Those guys want every
milliseconds matter. Maybe they do. I don't worry about such things. I'm almost all of my traffic is either web traffic or SSH traffic. And a couple of milliseconds isn't going to matter to me at all. But so if you're happy with IPv4, you're going to be able to keep on using that for probably your lifetime. But the future is going to IPv6.
There's this narrow problem that occurred. So in my experience, I worked for a company. We had a Class A network.
Yeah.
We were one of 256 of the entire network address space. And
Yeah.
we ran out of IP addresses in the building I was in. So they had policies that said this building gets this range, this building gets, and so I didn't have any choice. I had to basically switch over to IPv6, and then I used Squid, an open source like natting
proxy.
proxy thing, to reassign the addresses locally, and that worked out. So there is this hybrid kind of environment where you have part of your machines running IPv4 and then everything transferred over.
Yeah.
It works really well.
Yeah, and that whole problem goes away when everybody's doing IPv6. I just don't think you'll be able to count on it anytime soon.
Well, so the problem was that the network folks would not flip the switch on all the DNS servers to allow IPv6 because it was just too high of a risk, and they didn't have the funding to manage the risk on that. So I don't know if they're still discounting IPv6 in the company or not.
I don't know.
It was really kind of bizarre.
Yeah. Had a thought, now I lost it.
And all of that is, if you're talking about sticking with IP4, that's all the stuff that you voluntarily set up. There's all kinds of stuff that gets assigned to you, and they get IPv6 addresses automatically, like your mobile phone. Your carriers get an IPv6. You buy a car, and it has OnStar or that's GM,
whatever,
or any of these other services. All new cars, probably for the last 10 years, 15 years, came with a cellular modem installed in the car, and they're reporting back. Even when you don't subscribe to the service, I get notices from the manufacturer saying, "Oh, we see you have X number of miles on your car. It's due for service. You want to, set up a service appointment with us." Well, the only way they know that is the car's phoning home.
Oh, the car's talking to them. Yeah.
The car's talking to them, and it's talking to them over an IPv6 cellular modem. So you have stuff that you don't even know is on IPv6.
Yeah, that actually happened in the Baja 1000. One of the teams was running they were running a Ford Bronco, and it did an over-the-air update on its
I heard
its
something
transfer
about that.
case, and it was the ABS module, and then the ABS module like malfunctioned or something, and they had to. That's what they tracked it down to. They had to like reflash it back because it it wasn't working correctly or something, and it made them lose a couple hours, and they were all upset about it.
Yeah.
So Jim.
Yeah.
In my IPv4 home, I have some servers that I've fixed the IP address.
Yes.
And you just type it in Etsy hosts and do all the magic, and it works. How does that work in IPv6?
Well, you can do that, but if your address is changing all the time, that gets really tricky, right?
Yeah.
So if your address is being constantly allocated by DHCP, it's going to communicate with your DNS server and dynamically update it. But the cooler thing that I discovered is something well, first of all, I avoided IPv6 for the longest time. When I set up a Linux machine, I would disable IPv6 because I just got annoyed by listing my interfaces and seeing all those addresses that I didn't care about. So I just purposely disabled it all the time. But when I started digging into this and I turned it on some of the machines, it was on by default in my network. I discovered MDNS and Bonjour. If you're on Linux, I think it's Bonjour, or Avahi, I think is what it is on Linux. Anyway, if you have that enabled on your Linux box, and it's almost certainly enabled on your Windows and on your Mac, all the machines, you create a machine on your network. Like I got a machine called test.net or test-net. It's a virtual machine on my network, and I can hit that by going to test-net.local. Like I don't have to set up DNS for that. I don't have to add an entry to my host file for that. It's just available on my network as test-net.local. MDNS or Avahi or Bonjour takes care of that. So when a machine comes up on the net, it broadcasts its name and IP address, and all the other machines. Well, it's not really broadcast; it's a multicast. It'll multicast that out to all the other machines. So they will load it in their tables. So like my desktop can talk to my virtual machine just with that. It's really nice. I used to always go and add it to my DNS and send a HUP signal to DNS to reread the config every time I'd make a change. Now I can just build a machine, give it a name when I build the machine, I give it a name. When I boot that machine up, it broadcasts its name to everybody else. So I can hit it. And I thought that was pretty cool. And that's really, printers use that so that, when it gives you like printer discovery. Your printers are almost always available with a .local address on them. So you're adding that to a host file, your static IP address and your host name. You can just hit it by doing whatever your host name is .local.
And when your IP address for that host changes,
yep, it just rebroadcast or remulticasts it out to the network, so all the hosts get updated.
So everybody else knows where to go.
Yes. Plus, keep in mind, I mentioned how you get allocated a new address every 24 hours.
Yeah.
That old address will stick around like 6 days. So you can still talk to that machine at yesterday's address or the day before's address. So if you have an active connection between you and another machine on your network and the address gets deprecated and a new one gets allocated, you can keep on talking using that old address. It's not until like 6 or 7 days later when it gets purged that you can no longer talk on it.
And we assume that all the machines that may have tried to talk on the deprecated address will get informed that, hey, my address is now this.
Yep. Yeah, it's pretty slick.
Okay.
I'm an old school guy. I was used to static IP addresses and host tables, or at least DNS, and that's it. I lived by that. So I wasn't very quick to adopt any of this new stuff. This automatic discovery and all that kind of stuff. I was pretty slow about that. So I like to really understand what my network is doing. And now it's sort of getting out of my grasp. Now I just trust that it works.
Right. Well, when this all started, it was not IPv6 friendly, and it didn't work real well with IPv6.
Oh, yeah.
I remember setting up servers and hosts and all kinds of DHCP systems and stuff, and putting in IPv4 addresses.
Oh, gosh, yeah.
IPv6 for a long while. But yeah, I've been out of the business for a little bit now, and I'm sure by now it's probably AI generating stuff too,
Well, if you ever, if you have a network where you weren't running DHCP, have you ever booted up a machine and it's on your network and you didn't give it a static IP address, but it goes out and gets its own address that starts with 169 something? I'm talking IPv4. It would sort of create its own IP address. It starts with 169. That's a similar kind of thing. It'll allocate itself its own address, and it'll broadcast what that address is and what its name is. And so the .local thing isn't unique to IPv6. That's been out there for a long, long time. And I always avoided the 169 address, thinking it was ugly, but it's the same idea. So if you want to use IPv4, you still have this local discovery thing that happens. So you don't have to use DHCP or host tables.
Well, we ran into a situation where new servers were arriving on the floor, and it took 50 days, I think, was the thing to configure that and everything. And I was talking to HP about, well, can't you configure it for us? We'll give you like a list of names and IP addresses, and when you build the machine, you just plug that in, and then when it arrives, we'll just plug it in and and they could not even grasp the concept.
Dell will do that.
Yeah.
You buy a server from Dell, and I imagine maybe HP does now too. But you could actually, Dell would pre-configure that thing for you, assuming you were using an operating system that they supported.
Right. All the configuration would have to be something that they understood.
Yeah.
Well, maybe they do that now. This was back.
Yeah.
I don't know, 15 years ago or something.
Yeah, I think it happened because they're used to people buying. In fact, it's not uncommon to buy a machine, have it shipped to a data center, and have some network flunky at the data center just go rack it up for you.
Yeah, well, that's what it was. We had a team that just,
Yeah.
I mean, so there was these large data centers that you're putting thousands of servers into.
Sure.
And, there was this hallway with the stacks of the old ones that were on pallets. I'm talking about a dozen pallets filled with old servers. And so, this was a big time thing.
Yeah.
Perhaps someone have to go in and touch every single one of those. It was just, crazy.
So, the thing about it, data centers are kind of going out of fashion too now, right? With the cloud. I mean, there's still a lot of data centers out there, but for the most part, for companies like mine.
Controversy now. I was driving through Indianapolis recently. They have these huge data centers in the middle of the cornfields and all that. And there's big signs from the neighbors saying, no to data centers. They're going to start voting to disallow that. So there's a big controversy where they're using water and electricity, and the neighbors don't like that.
Yeah, well, down in Saline, their Oracle is going to put a huge data center down there, biggest in Michigan, the biggest project in Michigan, the highest usage of electricity in Michigan. And I don't know if it's totally approved yet, but they're talking about starting. If they can get final approval, it's going to start. They're going to break ground in January.
Just watching something on Slash.com that talked about there's like this meta group of folks that are complaining and saying they're not going to allow data centers, and 200 environmental groups.
Yeah,
I'll put that in the chat here. Yeah, so this is a big controversial thing now.
Yeah, people are saying it's raising all of our electric bills too. We're all paying for those. The enormous usage of electricity.
Yeah, here in Texas, it's water, so we're being told to use the water. I know in Detroit, we have the largest freshwater bodies in the world flowing.
It's less of a problem in Detroit.
Yeah.
And Detroit doesn't have the data centers, but it sounds like we're going to start getting them.
On 1007, there's an area around this area where they want to build a great big gigantic data center, and the people are complaining about it.
Yeah, it's probably Saline.
In the news last few days.
Yeah, everybody for the last month, everybody's talking about the one that's going to go in Saline. It's crazy.
Apparently, it's the noise too from all the cooling fans.
Yeah, I wonder. I hadn't thought about the noise problem.
Yeah, the ones that are doing, let's see, what was it? Bitcoin mining down in Texas. They're complaining that there's this loud noise all the time, 24 hours a day.
Probably like a humming or a droning sound.
And their animals are getting sick, and the people are getting sick.
Well, you've heard about this, the wind farms out on the offshore ones are killing the whales.
Yeah.
Secretary Kennedy
and causing cancer.
So I just shared a link that was given to me at EuroBSDCon, and they're basically that article is basically saying that these big AI companies they're renting data centers from companies that are spinning up to create data centers to sell the service to the AI companies, and just the money behind AI is so big. It's kind of like what happened with housing in 2008. So they think what's going to happen is same thing. Just too much money is going to get funneled into it. It's going to pop. And then we're going to have a huge issue on our hands with all this really expensive data centers that don't have any companies to support them.
That doesn't sound like my problem, though. I mean, it seems like the investors lost money in building a data center. I'm not sure why I care about their money. I think that thing about the cost of electricity, though, is real. Because the people who make the final decision on whether you can put a data center in or not are like a township in Michigan. So it might be Saline Township or Northville Township. That's a very small number of people, and they get tax money from the data center being there. But the electric rates are spread over, like a third of the state or something like that. All of DTE has the same electric rates across all of its its area. And the same thing with consumers and whoever else is in the business in Michigan. And so if you put in a data center in your township and it pays all your township bills, but everybody's electric rates in, a quarter of the state or something like that go up to feed it, I don't know. I mean, what do we do?
Yeah, the reason why the Europeans are so interested in this topic too is they're paying 6 times what we pay for electricity.
Oh,
why is that? Why?
Because their people decided to stop doing power that makes sense and switch back to coal, and just they made some decisions that they didn't really think through. Like, we're not going to do nuclear anymore.
Well, Fukushima scared a lot of people.
Yeah.
Right.
Yeah, but that was abject stupidity. Why would you ever put a data center in that? Anyhow.
Why do you think that the data center increases my price? Doesn't the data center pay for their electricity?
Okay, wait a minute. Hey, they do. But the data center does. They pay for their electricity, but they pay the same rate as every other, the commercial rate. They pay the same rate as everybody else does in all of DTE. Okay, so by using so much, DTE has to expand its generating capacity, and that costs more money. And so we all pay a little bit more because they're paying the same rate as you and I are. So you and I
up for me somehow. I don't know why.
Basically, I think what you're saying,
they're so big that they cause the whole rate, the whole cost of electricity over DTE's customer geographic base to go up.
It seems like the electric company could afford to buy more equipment and would be more efficient because they're not some little rinky-dinky place. You got the power of quantity, so everybody's price should go down.
Well, it's supply and demand.
Wait, one more on that. It seems that way. I agree with that. But it's coming out that it's not. Go ahead, Al.
Right. And the reason is electric utilities rate structure is based on return on capital investment. It's not based on how much electricity they sell. In a way, because they're guaranteed, they're a monopoly. As a utility, they're guaranteed a return, and the return is based on capital investment. So if people come along and say, we want to build data centers, and the utility says, okay, well, we're going to have to build new power plants and new transmission lines and new distribution lines, then they spread out the cost of all of that over all of the ratepayers. And that's why the rates go up.
So, Mark, I think what you were saying is that makes it bigger, and the rates should go down from that. And I don't disagree with that. But what's happening, the empirical evidence, what's actually happening is they're getting more money. The rates are going up because of that. And so that's what people are objecting to. And it isn't a lot, it's a few cents.
Please. Where's your evidence of that?
The rate bills.
Yeah, I just checked my latest bill. It's up to 20 cents a kilowatt hour. And just a few years ago, I think it was 15 cents.
There's no data centers here yet, so how can you blame them?
has to do with inflation.
I'm gonna have to ask my AI to fact check.
It's a good point. It's a good point. Those are the arguments, whether they're correct or not. I live in Northville, Michigan. Even the people here don't know where this is. So, maybe you're right. I don't know, but that's the argument, is that it's making our rates go up, and it's good for the people in the township where this gets built because they get the tax revenue for the for the operation there, but everybody else's rates go up because of it.
The problem's going to be is they're going to spend all this money, take it and get a loan to build the data center, and then AI bubble bursts, and that data center is worth nothing, and somebody's on the hook for paying for all that stuff in the past. You got to pay for it as you go to make this.
Whose money is it?
My
question
money. I got
is
my
whose
money on
is-
the AI
I mean, I
stock.
don't, if your 401k is invested in that fund, yeah, you got a problem. But if it's, some speculators and investors and they lost their money, I don't know why you or I care about that.
You dark clouds. Come on. Go buy some stock.
Well, it's a regulated monopoly, so we have to vote to allow them to raise the prices, and we're not allowing them to raise the prices. So what that means is that they're under investing in new capacity. So that causes the rates to go up. So it's conflicting with, because people don't understand they need to raise the rates.
Yeah, I
I
think
look forward to our new AI data center overlords taking over. I'm all for it.
So one more thought on this. Everywhere in the country is competing to bring in new businesses and new companies and new factories and stuff like that into their area. And every single business these days is electric intensive. I mean, stamping plants, auto plants, no matter what you're making, offices use a lot of electricity. So this isn't exactly unique to AI. It's just that they do generate and suck down a lot of electricity, and it's really noticeable for them.
A lot of people buying those electric cars these days.
I got one.
Anybody got a self-driving Tesla? Full self-driving?
No. I don't have a Tesla. I have a Toyota.
I another couple generations. I'm getting one.
Oh yeah, well yeah.
I swear I am getting one. That and a robot. Damn.
I know someone that has a Tesla, and he demonstrated how it can self-drive. Most of the time he's driving it, but it went on to 8 Mile and navigated to the turnaround and went around the turnaround and got to the spot we were supposed to be, that he told it was supposed to go to.
Wow.
My optometrist loves his. He swears that
The only thing I'm not sure about is how it knows, or if it knows what to do with a traffic light.
magic fairy dust in a big damn data center.
Magic fairy dust.
How about that AI from China, that breakthrough where they only needed like 10% of the compute to do the same AI job? That kind of disappeared. Maybe that wasn't all it was.
So what they're
cracked up to be.
suggesting is that they had the better NVIDIA chips, and they weren't revealing that.
Oh,
That was the thought on that it wasn't real.
That's one of the theories.
That's one of the theories that they.
I thought maybe we had a potential power savings there if it only used
Well,
10%.
if that was true, if it's true, then yes.
Yeah.
What was interesting is just yesterday, Trump allowed the sale of some of the better chips, the NVIDIA chips, to China, as long as they pay. I think NVIDIA has to pay 10% to the United States government. So somehow we're making money off of
export tax.
Yeah.
Actually, that NVIDIA AI reminds me of the podcast that you guys did recently, where you talked about the differences and how the Apple one doesn't have to move the data somewhere before it processes it. But the NVIDIA, like all the other ones, you kind of have to like move the data to the CPU.
Well, yeah,
There's
because
a lot of moving.
Apple has the GPU right on chip, right? I mean, it's what NUMA architecture. I mean, the GPU and the CPU can access the same memory, so it's.
Yeah, that was a good episode.
Yeah. Did you enjoy that? That was Wolf.
That was great.
That was Wolf's research. It turned out really nice.
But one more thing I was going to say about IPv6, where I'm at right now is I'm kind of in the same boat of I like my network how it is with the IPv4 stuff. So what I've done is I've created a Hetzner. Hetzner has servers that you can rent from them, and they come with IPv6. If you want IPv4, you have to pay extra for IPv4.
Oh, really? Okay.
Yeah. But they give you a nice little chunk of IPv6 space. And if you use that server as your container host, I use Jails, but you could do Docker containers if you're on Linux, then you can just build your whole network there and kind of get the hang of it and
Yeah.
start kind of wrapping your head around it.
Yeah, do all your experimenting and stuff that way. That's why, for me to research the stuff for the episode, I've got a XCP-ng hypervisor, so I could spin up Linux boxes, Linux VMs, as many as I wanted, and test the, different IP addresses and different options and stuff. It was really cool.
Well, but the one thing that you're not getting from that though is the public IPv6.
Well, I am, because I have IPv6
here.
But
so since.
But if you don't, then you're right. You're not going to get it.
Oh, and then the make an addressing plan. So I put a link on there for the RIPE. RIPE came out with a guide on how you should come up with your addressing plan. And so that's what I've done as well, is I come up with a little plan for, what types of things are going to have what kind of address. And I think that helps if you define it first before you start playing with it.
Yeah. One thing I don't know, I showed you the prefix that Xfinity gives me, that first 64 bits. It starts with 2601, I think. I have no idea if that's going to change on me, because the first 20 bits are always going to be the same, 2601 something something. But how about the rest of it? Is it like a static prefix? Or, if I reboot my router, could I get a different one? I have no idea.
So I talked to Massimiliano Stucci. He did a IPv6 tutorial at BSDCan, and he does a bunch of training on this. And he recommends, if you really get into it, to actually talk with RIPE or one of them and get your own block.
Yeah.
Oh,
there's one more thing I want to mention. Then we'll take Dick's question. But I talked about how IPv4 addresses are in short supply, right? If you have an old Class C that you actually own, you can sell it, and you can make an awful lot of money, like between $8,000 and $10,000 for a Class C. There's address brokers that you can sell it through. I have one, but I don't own it. The company I used to work for is gone. And we had a Class C there. It was a 198.201 address. And I tried to see if I could sell it, but my name is listed as the technical contact. I'm not listed as the owner. So and the company is gone. There's no transfer of ownership of that block of addresses to me. So I can't do anything with it. But if you have a Class C that was, that maybe got handed to you back in 1990s, you can sell it. Just look up IP address broker or something on Google, and you'll find information for that. Anyway, Dick, you had a question?
Yeah. Yeah. A2 hosting is no longer.
Yeah. What are they? Hosting.com now?
Hosting.com, but I don't think they have other than having a post office address, I don't believe they have a physical address in Ann Arbor any longer.
Really?
If you go to the website and you go down to the bottom of A2 hosting for the support, they don't have any support team in the U.S. any longer.
Oh, big surprise there.
And I set up for Soonvik.us. I tried to grab the US IP address.
Yeah.
And hosting.com will not support it. they said I've got to go through somebody else. So I've moved it over to my other provider.
Linode or
Linode.
yeah. They don't
So-
support. They can't handle that .us domain.
Well, the problem is the server is located in Toronto, and I don't know if that's part of the problem or not.
Interesting.
Yeah.
Huh.
So anyhow,
matter.
I'm going to be pulling everything out of A2 hosting eventually.
Yeah. Well, I'll tell you what, if you look at A2 hosting and you click on the About Us and you scroll down far enough to meet our teams, most of those people are not in the US.
Yeah, they got 3 different groups. None of them are in the US.
Yeah, so what did A2 hosting just sell out? Somehow they're still giving us a free platform
Well,
for
that-
mug.org.
Well, that is my concern.
Yeah, that might disappear.
Well, if I vacate A2 hosting and move over to Linode, which I plan on doing, I'm afraid they've got A2 hosting is on my account or
Yeah, but you're still going to have the
mug.org
A2
is-
hosting account, right?
Well,
I don't know how-
I'll be closing down my A2 hosting account eventually.
Well, we'll have to
Within
see
the
how
next
that-
6 months.
Well, we'll have to
And-
see how that works then.
Because they've got our address is on my account at A2
Yeah.
hosting.
Yeah, we'll have to figure that out. Anyway, well, what is it? 8:30, 8:35? Yeah, I need to get going. Just a reminder, January the 13th, we're going to be learning how airplanes do internet and live TV.
Wow.
From my brother. So that should be interesting. Look for the announcement on that fairly soon.
Sounds
And
great.
beyond
Yeah,
that, we need to.
I was on a
set some-
Delta flight just this a week, 2 weeks ago, and it was out. It would not give me any
Yeah.
internet access at all. So
Yeah.
somehow it doesn't always work.
Yeah. JetBlue takes that incredibly seriously, and sometimes they have problems. And my brother's team, they take care of that very. They'll take a plane out of service to fix that because they don't want any of their customers not having IP address or not having internet or TV. Anyway,
Well,
we get to ask them all about that in January.
Well, my last flight on Delta, I had no problem with internet. it's just-
I don't fly that much anymore, and I don't believe I've ever even tried the internet on the plane, on any plane. Huh. I don't know. I get on the plane, I want to put my headphones on and listen to like Miles Davis or something and just relax. I do not need to be on the internet when I'm on an airplane. That's my chance away from the internet.
Well, it was a chance to try it. What the hell?
Sure.
Yeah.
Sure. All right, well, guys, thanks for coming tonight. Look forward to next month, and have a great holiday.
Same to you.
You too.
Yeah. See all you guys.